So I'm Paul Elkington, I'm an Associate Professor at the University of Southampton and I lead the Tuberculosis Research Group. The tuberculosis pandemic unfortunately continues to kill 1.5 million people a year, and tuberculosis diagnostics have remained broadly unchanged for the last 100 years, mainly relying on sputum culture and sputum microscopy. We've been interested in how tuberculosis destroys the lung to cause cavitation and spread, and identified a family of enzymes, the matrix metalloproteinases, which drives this process. And we've used this knowledge to then study what fragments are released from the lung, and little fragments of collagen and elastin are released into the bloodstream and can be used as tests to identify the people who are most highly infectious. Interestingly, these haven't been found by other unbiased approaches, only by our hypothesis-driven approach. And so we're now using a new type of mass spectrometry developed by Spiro Garbis at the University of Southampton to identify all the matrix breakdown products released in tuberculosis. And the unique feature of this approach is it's a non-depletion based approach, and so we don't think the little fragments are going to be lost during the initial processing of the samples. So we're hoping to be able to come up with a test which can be used for population screening to identify and treat all of those people who transmit infection within the community. On its own, this would be no use without a platform which can be used for population screening. And so we've been working with Rob Easton in the Optoelectronics Research Centre, who have developed a laser patterning technique for paper, whereby they can mass produce cheap near-patient assays which could be combined with the matrix breakdown products for population screening. And so if we can develop this technology further, we believe that partnering people in high incidence regions to perform population screening would be a very powerful approach to controlling the TB pandemic, and thereby break the cycle of transmission, immediately reducing the toll of paediatric TB and significantly impacting adult